Welcome. In this video, I am going to use post estimation diagnostic tests for panel analytic regression models using Stata. Let me start with the outline of my presentation. I'll tell about the data and the variables that are used in this video. After that, I will use Hausman test. After Hausman test, I'll use time fixed effects tests, and I'll also discuss the Breusch-Pagan LM test for testing for random effects. Then Breusch-Pagan LM test for independence. After that, I'll use Pesaran cross-sectional test, and I'll be also using a test for heteroskedasticity and test for serial correlation, and after all that, I'll conclude my video. But before I discuss all this, I will open my Stata file, and my file is here. These are the various variables here that you can see. So I'll use my, in order to save time, I'll use my do file, and I'll give all the commands to tell the Stata to estimate all the models for me, and then I'll discuss one by one. So let me hit the return, the enter key, and all the estimations have been performed now. So let me start from the beginning. This is my first model, which is a fixed effect panel model, and these are the coefficients. These are the various coefficients in this model, and there are the standard errors. After this, I have stored the estimates for the fixed effect, and then I estimated the random effect model. These are the coefficients of the random effect models, and then I stored estimates for the random effect model, and after that, using this command Hausman FERE, I have these information about the Hausman test. Now these are the coefficients for the fixed effect model. These are the coefficients for the random effect model. This is the difference between the fixed effect coefficient and the random effect coefficient. The null hypothesis is that there is no systematic difference between the coefficient of random effect model and that of fixed effect model. Now the chi-square test value is 51.61 and the p-value is 0.000. So we reject the null hypothesis and we conclude that there are systematic differences in the coefficients of both the models. So we will use the fixed effect model rather than the random effect model, because there are systematic differences in the coefficients. After this, I estimated the fixed effect model with the year dummy, the time dummy, because I want to see if there is a time specific difference. And after that, I performed test parm I.er. This is for time specific differences, and here the null hypothesis is that the difference across all time is equal to 0. The test value is 12.27, but if p value is less than 0.05, so we reject the null hypothesis and we conclude that there is a time specific differences. After this, I estimated random effect model, which is this. These are their coefficients and standard errors, the z values and the probability of the z, and so on. And after that, I use xt test 0, and xt test 0 is a Breusch-Pagan Lagrangian multiplier test for a random effects model, and here is the result. After this, I regressed the FE model again, and I used this test xt test. So first I would like to show these results to you, and then I will discuss all these results. After this test was not performed because there are very few common observation across panel, so there are no results for this test. After this, I again regress the fixed effects model, and in this model I also use the Pesaran cross-sectional dependence test, but no results because it says the panel is highly balanced. After this, I used heteroskedasticity test, and the null is that there is no change, there is no difference in the variances across all i's or entities or states, and the p-value is less than 0.05. So we reject null hypothesis, and this is there is strong evidence for the presence of heteroskedasticity. Finally, I use this test xt serial, and then the rest is the model that we regress, and this is test for first order autocorrelation in the data. This is the f test value, and this is the p value of the f test, and since this is significant, highly significant, so we reject the null hypothesis and we conclude that there is the evidence of first order autocorrelation in the data. Now I would go to my slides, and I'll discuss these estimations. This is detail about the data that I have already discussed in my previous videos. This is the estimated fixed effect model. This is the estimated random effect model. This is the Hausman test, and on the basis of Hausman test, we conclude that a fixed effect model is better, and we will not use random effect model because there is the evidence of significant systematic differences in the coefficients of the fixed effect and the random effect model. And this is the testing for time fixed effect model. To see if time effects are needed, when running the fixed effect model, we use the command test palm, and it is a giant set to see if the dummies for all years are equal to 0. If they are, then no time effects are needed. But if you look at this test, the results shows that this is less than 0.05. So we reject the null hypothesis that the coefficient of all years are giantly equal to 0, and therefore time effects are needed in this case. This is our conclusion. After this, I'll discuss the Breusch-Pagan LM test for testing random effects. Now this is the model, and these are the results of the Breusch-Pagan LM test. The LM test helps us decide between a random effects and a simple OLS regression. The null hypothesis for this test is that the variances across entities is 0. That is, there is no significant difference across units, i.e. no panel effect. But if you look at this result, the test value and the p value, then we reject the null hypothesis and conclude that random effects is appropriate. That is, there is strong evidence of significant difference across countries. Therefore, we cannot run a simple OLS model. So we will go for random effect model. The random effect model is okay. After this, I am going to use Breusch-Pagan LM test for cross-sectional dependence, and this is the model. But as I mentioned earlier, because of too few common observation across panel, this test was not run. But if you have many common observation across panel, then you will have results for this test, and you have the p value, and then you can either reject or fail to reject the null hypothesis. This is Pesaran cross-sectional dependence test in fixed effect model, and again it says that the panel is highly unbalanced, strongly unbalanced, or highly unbalanced. So not enough common observations across panel to perform Pesaran's test. But if the panel is strongly balanced, then in that case you will have the test results, and then on the basis of test results we can decide whether there is cross-sectional dependence or not. This is test for heteroskedasticity. The null hypothesis of this test, xt test 3, is that the variances are homoscedastic, that is, there is no heteroskedasticity. But if you look at the test results, this is less than 0.05, the p-value is less than 0.05, so we reject this null hypothesis, and we conclude that there is strong evidence of the presence of heteroskedasticity in the data. After this, we will use serial correlation test, and the test is run like this. First we write this xt serial, and then we will write the model, the independent variable and the dependent variable, and then we get this value for our data, and this is also highly significant. So the null hypothesis is there is no serial correlation, but on the basis of this p-value we reject the null hypothesis, and we can conclude that data have first order autocorrelation. So my dear students and colleagues and subscribers, this is how we can perform various post estimation diagnostic tests for our panel data regression models. I hope this was helpful for you. Kindly subscribe to the channel and click on the bell icon. Thank you very much.